Okay, so this is homework 3, part 1, question 1. And in that question, it said that a customer flow within a grocery store, so the number of customers coming in at a grocery at a given time span, can be viewed as a Poisson process. The probability of the number of customers in 0 to t, where t is the number of minutes in this case, is equal to k, where k is the number of customers, is equal to e to the negative lambda t times quantity of lambda t to the k divided by k factorial. So the first part, we're asked to find lambda, and we're given that the probability in 2 minutes of at least one customer arriving is equal to 0.5. And so that's equivalent of saying that the probability of where our random variable, k, but I'm going to write it as x is greater than or equal to 1, because that's at least 1, is equal to 0.5. And so this can be rewritten to make it easier for us to do computationally as 1 minus the probability of no one occurring. It's also equal to 0.5. And so this, now we simply just plug in, and it's 1 minus e to the negative lambda 10, because, oh, not lambda 10, lambda 2, because it's in 2-minute time frame, times lambda 2 to the 0, because there's 0 customers, divided by 0 factorial, is equal to 0.5. And so we can move the 1 to the other side, and this quantity is equal to 1 because a quantity to the 0th power is equal to 1, and 0 factorial is also equal to 1. And so we get e to the negative 2 lambda is equal to 0.5. And we can take ln of both sides. We end up with negative lambda 2 is equal to the natural log of 0.5. And then when you divide both sides by negative 2, you end up getting lambda is equal to 0.3466. So I'm going to write that inside because we're going to need it in the future. Lambda is equal to 0.3466. Okay. Part 2, we're asked to find the probability that in 10 minutes at least 2 customers will arrive. So that's equivalent to saying the probability of where x is greater than or less than 2. So we want to find that. Just like we did last time, we can also flip that around. So probability of x is greater than or equal to 2 is also equivalent to 1 minus the probability of where x is less than 2. And x is less than 2 when x is equal to 1 and x is equal to 0. So this, when we plug it in, because in this case it's in a time span of 10 minutes, t is going to equal 10. So it's going to be e to the negative 10 lambda, 10 lambda to the k. In this case, our k for the first part is equal to 1. And then we have e to the negative lambda 10 again. K is, lambda is equal to 10, but k is equal to 0 in this case. So this, like last time, just goes away. So it just equals e to the negative lambda 10. This just ends up equaling 10 lambda, so we can rewrite that as e to the negative 10 lambda times 10 lambda minus e to the negative 10 lambda. And then since we know that lambda is equal to 0.3466, we can just plug in lambda. And after we plug in lambda, it comes to probability is equal to 0.86. So we're going to write that inside. The probability where x is greater than or equal to 2 is equal to 0.86. Alright, part 3. So for part 3, we're asked to find the probability that exactly one customer will arrive in 1 minute. So that's equivalent to saying the probability of just x equal to 1. And so that's just e to the, since it's 1 minute, e to the negative lambda times lambda to the k, which is equal to 1. Let's write that, divided by 1 factorial, is equal to e to the negative lambda times lambda. And when you plug in lambda, you end up getting 0.245. So that is number 3. The probability of x equal 1 is equal to 0.245. Finally, for part 4, we are asked to find the probability that in 3 minutes no customer arrives. So that's equal to the probability of x equals 0. And so we have e to the negative lambda, and it's 3 minutes, so it's 3 times 3 lambda. So k is equal to 0 to the 0 divided by 0 factorial. Once again, this just ends up equaling 1. So it's just e to the 3 lambda. You plug in lambda, and you get this probability is equal to 0.3535. So 4 is equal to the probability of x equaling 0 is equal to 0.3535. And that's part 1.